All right. So now we're at the point where we can go ahead and go to File, open up the script if you haven't done so already. All right. Again, just to remind you, we can go ahead and set our working directory. Again, you're going to have to change that from the script that you have available to you. You're going to have to set it appropriately for your computer. Okay. So again, the first thing that we need to do is we need to change our working directory to make sure that the path is set to the folder with the script and with the data. Okay. And so then the next step is that we're going to go ahead and read the data in. Okay. And if you want to do a little exercise, you can compare the first script from the first module with this script, and you'll notice that here we're using a read.csv. Before we used a read.table, and then in here we had a little bit of a line that told us that in fact the table is in CSV format. Okay, so you can compare those, right? Just two different ways to read in the data. Here, read.csv, we don't actually have to tell it that it's a CSV because we told it here. We brought in the data, we can check it. So this command dim stands for dimensions. Okay, so dimensions of data 1, there are 112 rows, 7 variables. We can use head and tail to look at that, right? What we're seeing here is that in the first year in 2014, we took ratings at 3 different time points, but we didn't get it in the last time point for 2015. Okay, so there's some missing data, right? That happens. Okay, use structure to look at the data, and so it's telling us that year is being treated as an integer, genotype as a factor, inoculation as a factor, rep as an integer, and then our stand counts are integers also. So this is important to note that year and rep are being considered integers, okay, because we don't really want them to be integers. They are factors. It's just that R is interpreting them as numbers, right? So that's something to keep in mind because we're going to have to approach that. So now we have our data read in, we can use the box plot command, the famous box plot command, okay? And in this case, we haven't attached our data, so we have to tell it that I'm in the data file called data1, and I want to look at the distribution of the July stand counts relative to inoculation, right? And then the rest of this, I'm setting my labels, X labels, Y labels, giving it a main title, and I'm saying color it blue. All right? And so what do I see when I look at this distribution? Does it matter whether my soil has been infected with Rhizoctonia or not? Looks like it may matter. Right? Okay. Okay, so in this second slide, I'm just kind of defining what these terms are telling us. Okay. All right. So what I'm going to do now is I'm going to rearrange the data. Okay. So I'm going to create a new object that I'm going to call new data. Okay. And I'm going to, for my file data1, is I'm going to order that file based on the inoculation column. So when I look at the head and the tail of new data, what I see is at the top of the file, I now have the Rhizoctonia treatment, and at the bottom of the file, I have untreated. Okay? And then again, look at my dimensions. My dimensions are the same as they were before. Okay? So I've ordered my data based on that inoculation method. Okay? So now I'm going to take that object that I created called new data, and I'm going to tell it to give me row 1 through 56. So here's the notations here, right? This bracket, the square bracket, is telling me about the dimensions of a matrix. And I'm saying that I want rows 1 through 56, and then comma, and I'm leaving column empty. So I'm taking all of the columns, but only in row 1 through 56. And I'm writing those out to a new object called new data. All right? And when I look at the head and the tail, you see that, especially on the tail, you see that I no longer see any untreated, right? I've only got, so what I've done here is by ordering my data, sending the inoculated part to the top, and then writing that out, I have a new set of data with the dimensions of 56 by 7 that only contains the inoculated data. Right? So I've just rearranged my data and partitioned out a piece of it. Okay? So new data 2 has only data for plots that are inoculated with Rhizoctonia. Okay, so what we've done is we've partitioned the data, and now we can do a box plot of that new data focusing on the stand counts in July. Okay? And we can compare it to, or we can use the genotypes there to look at it. Okay, and so now we get a feel for the distribution of our data under inoculated conditions by variety. Okay, and what we see is that we appear to have some variation in there. Right? We appear to have some where we don't get much of a stand count and some where we do. Right? Okay. So we still have done no statistics. We're just sort of visualizing the data. Okay. All right. So we're using the new data 2 file. We're setting labels. We're setting titles. The other thing that I've added here is I've used this LAS equals 2 command, and that sets these as vertical rather than horizontal. Right? So a few tips there on how to graph things and make it look nice. Okay? So again, we can look at our data distribution and we can consider whether a transformation is needed. Okay? And so here I'm giving you the code that can be used to fit a normal curve over our data. So it gives us kind of a reference. In this case, notice that there's two things that I've done here. One is that we have some missing data in our data set. And so we can use this NA-omit to remove missing data. Because the mean and the standard deviation commands here won't work with missing data. So we have to remove that. Then the other thing that I'm doing is I'm setting x to a log 10 of 1 plus x. So it's a transformation of the data. Okay? So in your code, in the script, you actually have both. So I'm running it just on the stand counts in June. And you can see that that distribution really doesn't fit a normal distribution very well. Okay? And then I'm running it on the log 10 of 1 plus that stand count. All right? And I'm going to admit that that second one doesn't really look like a good normal distribution either. But it looks better than the first one. Okay? So I may want to consider analyzing my data both on the raw data as well as on a log transform data. Okay? Nothing that we've done constitutes a statistical test. All we've done is explored the data. Okay? And so now what we want to do is an analysis of variance.